Many causal questions are about the effect of some treatment on a lifetime outcome. For example, what's the effect of going to preschool on your lifetime earnings? How much money you make over your entire life? Or what's the effect of having health insurance today on whether you die of a heart attack, which may happen, hopefully, very, very far into the future? So in some experiments, like the Perry Preschool Project, the treatment was done so long ago, the experiment is so old, that we actually have data on lifetime outcomes. And we can answer questions like this using our experimental data. But in others, like the Oregon Healthcare Experiment, which was just done a few years ago, is just too new to know about outcomes like whether these people in the experiment are going to die of a heart attack. What we have to do is just wait another 50 years, and then with this data from the Oregon Healthcare Experiment, we'll be able to know the effect of having Medicaid in those few years on whether people died of a heart attack. But the problem is we want to use this experimental data today to make policy decisions today. We can't wait 50 years from now. So what are we going to do? Well, one common solution is to use something called a proxy variable. These are variables that are correlated with the outcome of interest, okay? And they're thought to have a causal effect on the outcome of interest. So in the Oregon experiment, we can't look at the effect of having Medicaid on whether you die by a heart attack, okay? Because everyone's still alive. So we don't know how they're going to die. But what we can do is look at the effect of having Medicaid on your cholesterol. And then we use our scientific knowledge that having lower cholesterol is going to make you less likely to have a heart attack to get to the second step of what's the effect of having Medicaid on whether you have a heart attack or not. Okay? So if from the experiment we learn that having Medicaid lowers your cholesterol, then we also conclude that having Medicaid will lower your risk of dying from a heart attack because we know this second step from our scientific knowledge that lower cholesterol makes it causes you to be less likely to die from a heart attack. So the problem with this is that it relies on this extra step of having knowledge that the proxy variable, cholesterol, actually affects the ultimate outcome of interest, whether you die of a heart attack. So if you actually observed in the data whether people died of a heart attack or not, you wouldn't need this extra step. The experimental data would be sufficient. But without actually observing that outcome in your data, you're going to have to make some assumptions about how this proxy variable affects the outcomes you actually care about. Now, this is actually not a problem with just experiments. It's a problem in all research, whether it's based on experimental data or observational data. But the difference is, in observational data sets, you usually do observe the outcomes you actually care about, okay? Because these data sets are very large, have surveys sort of every year for many years. So often the data goes back a long ways, and you can actually observe what you care about. In experiments, however, you usually do have to wait many, many years once you've run from an experiment before you can observe the outcome you care about. So that's why proxy variables are usually more of a problem for experiments than they are for observational data.